Hello? Welcome to today's lesson on Newton's first law and its application in everyday situations. In this lesson, we will explore how an object in uniform motion continues at the same speed and direction unless acted upon by an external force. Next, we will look at the role of unbalanced forces in changing an object's speed. Finally, we will understand how external forces change an object's direction. So far, you have developed an intuitive understanding of Newton's first law. You've learned that an object will remain at rest or move with uniform velocity unless acted upon by an external force. Building on this foundation, we will now see how Newton's first law helps us understand everyday scenarios, enhancing our broader knowledge of forces and motion in the real world. Let's get started. Let's begin with understanding uniform velocity. Newton's first law tells us that an object moving at a uniform velocity will continue to move at that velocity in a straight line unless an external force acts upon it. The phrase uniform velocity means the object maintains the same speed and direction. Consider a scenario with a toy car moving across a very smooth table. If you push the car and then let it go, it will continue moving in a straight line at a constant speed. Why does this happen? It's because the table is smooth, minimizing friction, an external force that would otherwise slow the car down. So, in absence of significant external forces like friction, the toy car maintains its velocity due to inertia. We'll touch on inertia in the next lesson, but for your understanding, inertia is a concept that describes the tendency of objects to resist changes in their state of motion. This example clearly illustrates how Newton's first law applies to objects in uniform motion. Now, let's explore how objects change speed. According to Newton's first law, an object will only change its speed if an unbalanced force acts on it. This could mean speeding up or slowing down. Imagine a car at a stop sign. When the driver presses the accelerator, the car starts moving from rest. The engine generates a force that propels the car forward, overcoming any stationary resistances like friction from the road or air resistance. This unbalanced force, the engine's push, acts on the car, leading to a change in its speed. Similarly, if the driver hits the brakes, the car will decelerate because the braking force, an external force, slows it down. Thus, acceleration and deceleration in cars demonstrate the role of unbalanced forces outlined by Newton's first law. Lastly, let's discuss changing direction. According to Newton's first law, an object will continue moving in its current direction unless an external force causes it to change direction. Consider a car making a sharp turn. Initially, the car moves in a straight line. To make a turn, the driver must steer, and the tires interact with the road to create a force that changes the car's direction. Without this force from the tires, the car would continue in a straight path due to inertia. Another simple example is throwing a ball. When thrown, the ball travels in a straight line unless acted upon by external forces such as gravity and air resistance, which alter its trajectory. These examples of turning cars and thrown balls show how an external force is essential for a change in direction, reaffirming Newton's first law. In today's lesson, we applied Newton's first law to real-life applications, looking at three key things. Firstly, we looked at uniform velocity. Objects move at a constant speed and direction unless acted upon by external forces, as shown by a toy car on a smooth table. Secondly, we looked at changing speed. Unbalanced forces, like an engine's push or braking friction, are needed to accelerate or decelerate objects. Finally, we looked at how objects change direction. External forces, such as steering a car or gravity acting on a ball, cause directional changes. Understanding these principles helps explain the forces and motions we observe in daily life. Watch the rest of the GCSE physics course at Sophos Education.